All right, let's just dive right in. We're looking at the ultimate architectural blueprint for building the next generation of dental revenue cycle software. Look, if you're building tech in this space, you already know we're hitting a wall. The industry is shifting dramatically in 2026. So, in this explainer, we're going to map out exactly how you engineer your way through it, pulling insights straight from the latest technical frameworks, legal analyses, and industry data.
Now check out this number from a recent Zentis report, 58%. That is the chunk of dental practices officially committing to automation by 2026. Why the sudden rush? Well, because the manual workload has literally become unsustainable. We're right in the middle of a massive transition where scalable systems aren't just nice-to-haves anymore. They are absolute, fundamental operational requirements.
So, to build this software right, we're going to break down the exact layer-by-layer blueprint you need. We'll hit the dental efficiency paradox, architecting the cloud foundation, integrating the AI engine, next-gen automation workflows, and wrap up by navigating those tricky 2026 AI regulations.
Okay, part one, the dental efficiency paradox. We've got to start with the foundation, right? Understanding the massive friction points we're actually trying to engineer our way out of. Just think about the hidden costs of legacy manual billing versus the seamless flow of Automation 2.0. On the legacy side, your users are completely bogged down. I mean, they're dealing with portals that constantly change their UI, multi-factor authentication resets, those annoying CAPTCHAs, and, let's be real, endless hours of payer phone hold music. It stretches out AR days and totally burns out staff. Now flip that over to Automation 2.0. Here, we're relying on API integrations, predictive scoring, and agentic AI that just handles it, only pinging a human via Slack or Teams for the really weird edge cases.
This whole situation is perfectly summed up by Otto Kasimov, the CEO of Zentis. He points out that practices are maintaining strong collection rates, but they're doing it at a skyrocketing operational cost. Keeping up that performance in 2026 is requiring an exhausting, totally unsustainable amount of human labor. That's the efficiency paradox in a nutshell, and it's exactly why scalable AI systems absolutely have to step in and take over the heavy lifting.
Moving to part two. Architecting the cloud foundation. To actually solve that paradox, we have to lay down a rock-solid data foundation using modern cloud architecture.
To smash through those data silos and scale efficiently, your 2026 software has to leverage both SaaS and DaaS models. According to the latest architectural frameworks, you need the standardized operational functionality of software as a service married to the centralized real-time streaming power of data as a service. You're going to be handling a staggering volume of dental records and incredibly complex EDI 837 claim files. Your underlying infrastructure simply cannot collapse under that weight.
So how do you actually build that data pipeline? It's really a three-step process. First, securely connect to disparate practice management systems, your Dentrix, your Open Dental, using unified APIs. Second, you extract and standardize all that data using healthcare interoperability standards like HL7 and FHIR formats. And third, you channel that pristine, real-time data straight into an advanced analytics platform.
Using a cloud-native architecture like Snowflake gives your software some massive advantages. It lets you separate compute and storage resources, meaning you can scale them independently based on your actual workloads, which drives huge cost efficiency. Plus, it natively handles semi-structured formats like JSON and XML and automates your EDI 837 transaction formatting. But here is the real kicker for healthcare. Its time travel functionality gives you the comprehensive data lineage tracking you absolutely need for strict regulatory compliance. All right, part three, integrating the AI engine. Now that our cloud data layer is built and scaling, it's time to install the brain that's actually going to power the revenue cycle.
To get this right, we have to pull data straight from the clinic floor. Your software needs to empower healthcare teams by making sure clinical data, radiographs, and even telehealth encounters are properly extracted, standardized, and fed directly into your AI processing engine.
Now, this is where it gets incredibly fascinating. By integrating FDA-cleared computer vision and natural language processing, think platforms like Overjet, your software can automatically analyze radiographs with clinical precision. It recommends the most accurate CDT codes and, crucially, flags missing documentation or coding inconsistencies before a claim is ever submitted. This proactive, preventative capability, that's what radically reduces downstream denials. But what happens once the claim actually goes out the door? Look, we all know simple RPA scripts break the second a payer updates a button on their website. Instead, we have to build agentic AI, Developers like Ventus AI define these as browser-native agents that essentially behave like trained human teammates. They log in, they navigate complex security friction like CAPTCHAs, they grab claim statuses, and then, this is key, they seamlessly escalate only the really tricky edge cases directly to your human staff via Slack or Teams. Basically, let the AI do all the tedious clicking.
Which brings us to part 4, next-gen automation workflows. Let's look at how this AI engine actually performs in the application layer for the end user. These Automation 2.0 workflows take your software from just automating past tasks to actively predicting the future. We are talking about predictive claim scoring before you even hit submit, intelligent eligibility checks that scan across multiple payer portals at the same time, and automated AR tools that prioritize your highest value claims first. And for large dental support organizations, this all rolls up into unified multi-clinic dashboards. You can track denial trends and forecast seasonal revenue across every single location.
All of this ultimately builds toward a massive industry shift experts are projecting for 2026. We are moving away from that slow, multi-week, lag-based waiting game and replacing it with instantaneous, real-time claim reimbursement. Your software architecture absolutely has to be fast and smart enough to support this new real-time reality.
Finally, Part 5, Navigating 2026 AI Regulations. This is the last layer of our blueprint, where we build the compliance shield.
You simply cannot deploy advanced AI in healthcare without rigorously navigating a total surge of new rules. Building this software means strictly adhering to a cascade of state laws that kick in on January 1st, 2026. For example, California's AB 489 says AI cannot imply it has a medical license. Texas's TREGA law mandates conspicuous written disclosure if AI is used in diagnosis or treatment. Now, the federal government is trying to establish a single national framework via executive order that might preempt some of this. But as an architect, you have to impartially design your system to comply with state-level transparency tools today while keeping things adaptable for whatever federal standards ultimately shake out.
Because you're introducing third-party AI models into the highly sensitive healthcare supply chain, your system architecture has to integrate ironclad security. We're talking about strictly enforcing multi-factor authentication, data encryption both at rest and in transit, and continuous, automated security monitoring to catch vulnerabilities long before they're ever exploited.
You also need to pay close attention to the new rules surrounding Business Associate Agreements, or BAAs. Based on Health Sector Coordinating Council guidelines, your BAAs now need specific AI enhancements. You have to explicitly prohibit using protected health information to train public or third-party models without consent. You have to enforce the minimum necessary standard, meaning the AI only accesses the exact patient populations it needs. Plus, you're looking at expedited breach notification timelines, like 2 days for AI-related incidents, and strict flowdown rules for any offshore developers touching your code.
And finally, developers have to rigorously audit their vendors' transparency. You need to ensure everything from the underlying training data sources, like California's AB 2013 requires, to model accuracy metrics are thoroughly documented. You also need really explicit end-of-life data destruction protocols. You've got to make absolutely sure patient data never lingers in a retired obsolete AI system once a model is decommissioned.
Which brings us to our final thought. As you go out and deploy this architectural blueprint, from the Snowflake Cloud Foundations through the agentic AI workflows all the way up to those compliance shields, ask yourself, are you building software designed for the manual workflows of yesterday, or are you engineering the compliant, AI-driven reality of 2026? How will you continually adapt your tech stack to stay ahead of the efficiency paradox? Thanks for joining me for this explainer, and I really hope this blueprint helps you build a future of dental revenue cycle software.